Hello guys, and welcome to Electronics. In today's video we are in another set of limits called conjugate method. So in this method the conjugates of binomial expression such that an expression has with two terms. You can tell this because the Latin root by means true. So when you have, let's say, a plus b, so it's just with the same expression with opposite middle sign. Let's see another one with a minus b, in such a way that difference of two squares. So with opposite middle sign as this, square of this minus square of this. The conjugate of the, let's say, so if you have the conjugate of, let's say, if we have this root of a minus b, so the conjugate of this is equal to what? Root of a plus what? V. It's just root of a. If you have root of a minus v, is the conjugate of this. If this is a given function f of x, so the conjugate of this, that's conjugate, is equal to what? Root of a minus v. So this is the conjugate, and this is really useful if you have a radical in your limits. This is because the product of the two conjugate containing radicals will and itself contain no radical expression. See, so as if you have let's say root of, let's say, x minus 5, and you know the conjugate of this is going to be equal to what? Root of what? X plus what? 5. So if you multiply this together, since it's different of 2 square, it will give you what? Root of what? X square minus what? 5 square. So you just take the first one, square it, and then the second one, square it with the negative sign. Likewise, you can open the parentheses by saying this time is this, we have a root of x square, so definitely this go with this as this. Yes, so you know here this square goes with this square, so we will have x minus what? 5 square, which is what? 25. So likewise here, if you add this times this, we have what? This multiplied by this is this multiplied by 5, you have what? 5 root of what? X, and then here if multiplied by this, negative 5 root of what? X, and then negative 5 minus positive 5, you have what? Negative what? 25. So this go with this, we have root of x square, we have x, then minus what? 25, which is what? X minus 25. So basically, if you like, you can open parentheses, that's bracket. If you like, you can just take difference of two squares and proceed. Take the first square and then negative in the middle, and then the other one squares. So this is how the conjugate is working, and it's just what? To take the square of a and b also at the same time. So we're gonna take some questions and solve it using conjugate method and see how it's going to be. So also, if you use substitution method in this particular question, there is no going to give you answer rather than to give you a 0. So let's use let's take for the first question. Let's say the question 1, we have a limit at x approaches 5 of this. So let's substitute using x to be equal to 5. So we have root of what? 5, since it's x plus 1, here is plus 11. Root of what? Here is just x. So let me change the fan. So let's see. Okay, so x approaches to 5, we are going to put it here and then the here, and see whether we can use the substitution method. And so we say root of x, our x is 5 plus what? 11, or here is minus 4 all over what? Our x is 5 minus 5. So here we have 5 plus 11 is root of what? 16 minus 4 all over what? 5 minus 5. which is 0. So here is root of 16, we know is 4 minus 4 all over 5 minus 5, which is 0 over 0. So basically you are not going to use substitution rather than to use conjugate method. To do conjugate is very easy, as I show you. If you have a root of a plus b, the conjugate of this is going to be equal to root of a minus b. It's not the different sign between them. If you use plus, is add negative. If it's negative, just change it to what positive. So we're gonna start from with question 1. Question 1 is just what limit x goes to what 5 of what root of what x plus what 11 all over what minus 4 all over what x minus 5. So as you see here, since we have this, so here is already factorized. Our consign is on the top, so we are going to add the conjugate of this, and here we have negative sign, so we are going to add the positive sign. So you can see root of what, let me go down, so you can say x plus what 11 in the root, then minus 4 all over what x minus 5, then multiply by we're gonna take the conjugate of off, so we can see root of x plus 11 altogether. Then here we are going to, since here is negative, here we are going to add positive, so we can say we can do the same, x plus 11 plus what 4, since this one can go with this one mathematically, so it left you with this. So there is nothing new, it's just mathematics. So let me cancel this. So since here is already this, we're gonna multiply the top and bottom together. So looking carefully, by looking carefully, here is the same. Let's say if here is a, here is the same as a. Is the only difference. If here is b, here is b. The only difference is just sign. So this is the difference of two square. If you like, you can open the parentheses. This one times this one, and this one times this one also. So it's just difference of two square. So if you like, you can say if you have such, this is just a square minus what b square. So we can take the whole this. We can say root of what 11 x plus 11 the whole square minus, here is just 4, so we can say minus 4 what square. So and then likewise you can open parentheses by saying this time is this, you have also this square, and then this one times this one, you have positive, this one times this one, you have positive what 4 into what root of what x plus what 11, and then the other one is negative 4 into what root of x plus what 11, and then the last one is what minus 4 times a positive 2, 4 is just what negative 16, and then the first one is already this x plus 11 whole square. So basically this one will go with this one, so it will remain this one. So no need to just open parentheses, just take the difference of two square. So here is in the off, so in the bottom we have x minus 5 into what root of what x plus what 11, on the other part we have what 4. So we also say this to be equal to what x plus 11, this square go with the root, so we can say x plus what 11 then minus what 16 all over what x minus what 5 into what times this into what root of what x plus 11 x plus 11 sorry, and then plus what 4. So here we can say x plus 11 minus 16, we have what x minus 5, and then in the bottom we have x minus 5 into the other part is root of what x plus 11 and then plus 4. So lastly x plus 5 go with what x plus 5. So we'll end with what 1 all over what root of what x plus what 11 what plus what 4, and then our limit is what limit x approaches to what first 5. So we can say 1 all over what root of what 5. We're gonna substitute x to be equal to 5. So wherever you see x, just replace it as 5 plus 11 and then plus what 4. Then we can see 1 all over root of what 16 plus what 4, and then root of 1 all over what root of 16 is 4, and then plus another 4 we have which is going to be equal to what 1 over 8. So limit of this function as x approaches to 5 of root of x plus 11 minus 4 all over root of all over x minus 5 is going to be equal to what 1 over h. So let's take another questions, and the next question is limit x approaches to negative 2 of what x plus 2 all over root of x plus 6 minus 2. So the question 2 is given. Let me change frame. The question 2 is given. Question 2 is given as limit at x approaches to what negative 2. The function is given as what x plus 2 all over what root of x plus 6 then minus what minus 2. So here if you look carefully, at the top is just x plus 2, and then at the bottom is just what that's where we have problems. And then if we substitute x to be equal to negative 2, we will end with for this function. This is going to be equal to 0. As if you substitute 2 minus 2 plus 2 is 0, and then the other one minus 2 plus 6 is what 4, and the root of 4 we know is 2, and then minus 2 which is equal to minus 2 which is 0, then 0 over 0 is Faraday's function. So we're gonna use a conjugate method to evaluate the given limits. So we have x plus 2, and then for the denominator we have what x plus 6, and then minus 2 here. So the conjugate of the bottom is what if you have a plus b, root of a plus b, the conjugate of this side is what root of what a minus b. So we're gonna take the same but what different sign, so with up and down. So we're gonna say x plus 6 first of 2, that's plus 2, and then for the lower, for the denominator we have x plus 6 then plus 2 also. So it's nothing if you say this go is this, it will still remain what this. So we're gonna multiply both numerator and denominator at the same time. So for this we have x plus 2 into the other one we have a root of what x plus 6 and then plus 2 right here, and then for the numerator we have here is the same as here, and then here is the same with this. The only difference is just sign, so it's different of 2 square. We can say x plus what 6 all together square, then minus what 2 square. If you like, you can open the parentheses, you can open the bracket like this. You can say this times this, you can open, you can multiply by using expansion. You can do this a plus b a minus b. You can factorize this, you have a square minus ab plus what ab minus b square. So this goes with this, so no need to compute the parentheses. So we have x plus 2, and then root of x plus 6, then plus 2, and then for the lower for the denominator we have this square goes root, then we have x plus 6, then 2 square is what, 4. Then we can say x plus 2 into what, x root of x plus 4 plus root of x plus 2 together. The x plus 4 is in the root, and then the plus 2 is independent, and then it is independent to the root, so the root doesn't contain 2. So the denominator we have x plus 6 minus 4, we have x plus what, 2. So this go with this. Then we will have root of what, x plus 4 all together, then plus 2. So since we have this, we're gonna substitute. Our limit is what, our limit is what, x approaches to what, to -2 of this function. So of this root of what, x plus 4, then what, plus 2. So we have to substitute x as 2. So we can say here we have -2 plus what, 4, and then sorry, -2 plus what, 6 is 6 right here, plus what, 6, then plus 2. So we can also say -2 plus 4 is root of 4 plus 2, then 2 plus 2 is equal to what, 4. So the answer is going to be equal to what, 4. So 4 is the given answer. So the last question is what I think is pretty good. We can stop here, but the last question is for homework. Is limit, to find the limit at what x approaches to what, -2. Also at x approaches to what, -2, the function is given as root of what, x plus what, 10, and then -3 all over what, x plus 1. So it's very easy. What you are trying to, if you put -2 using substitution, it's not going to give us answer. So it's what, root of -2 plus 10, which is what, -3. So it's not going to give us answer. Rather than to use, sorry, I mean here is plus 1, sorry, as x is equal to what, at x equal to what, -1. So if you put -1 all over what, -1 plus 1, here is what, here is 10, here is what, it will become root of 9 minus 3. Root of 9 is what, 3. 3 minus 3 all over what, 1 minus what, plus 1. This is 0 over 0. So you have to use what, by what, by conjugate method. So it's very easy. Just multiply by the conjugate of this, which is what, root of x plus what, 10. Then here is negative, we add positive for the button and off, and then here is root of x plus 10 plus what, 3. So you have to just, you know, multiply them, try to what, find the numerator prime to find the factor that will go with what, x plus 1. So it's okay. I don't think that is different. And then the answer is 1 over 6 answer. So it's homework. The answer is 1 over 6. So it's pretty good and very easy. So don't forget to subscribe, give a like and comment. Thank you for watching. See you in the next video.